My name is Dr. Alfred Musekiwa. I'm a senior lecturer in the School of Health Systems and Public Health at the University of Pretoria. I welcome you to this session on confidence intervals for the mean and for the proportion. The purpose of this session is to explain the interpretation and calculation of 95% confidence intervals for the mean and proportion. Remember that statistics has two branches, descriptive statistics and statistical inference. We have already covered the descriptive statistics that deals with summary statistics such as means and standard deviations, as well as data presentations such as bar charts and pie charts. In statistical inference, we deal with generalizing results from a sample to a population. We do it using two methods, confidence intervals or hypothesis testing. In this session, we will talk about confidence intervals. The 95% confidence interval for a population parameter is the interval in which we are 95% sure that the parameter lies in. The formula for the 95% confidence interval for the population mean mu is given by sample mean plus or minus 1.96 times SE. SE is the standard error. And if we are doing the mean, if we are doing the calculation for the mean, the standard error is given by a standard deviation SD divided by the square root of the sample size n. The constant 1.96 comes from the standard normal probability distribution that we will cover later. Here is an example showing the steps for calculating the 95% confidence interval for the mean. A study in the USA set out to determine mean cholesterol levels in different groups. The number in the sample was 749. The mean was 5.1 mmols per liter. The standard deviation was 1.4 mmols per liter. Therefore, we can calculate standard error, which is 1.4 divided by square root of 749, and we get an answer of 0.05. We continue with the example from the previous slide. Remember that the mean cholesterol level in black men in the USA calculated from the sample was 5.1, and the standard error we calculated by dividing standard deviation by square root of n, which was 1.4 divided by square root of 749, and we got 0.05. 1.96 times standard error, which is in the formula, is going to be 1.96 times 0.05, and we get 0.1. To calculate 95% confidence interval, we will say the mean, which is 5.1, minus 1.96 times standard error, which is 0.1. So it will be 5.1 minus 0.1 will give us 5.0, which will be the lower limit for the confidence interval. For the upper limit, it's going to be 5.1 plus 0.1, which is 5.2. Therefore, we can interpret this result by saying with 95% assurance, mean cholesterol in black men in the USA lies between 5.0 and 5.2 mmols per liter. Now we move to the 95% confidence interval for a sample proportion. We'll find that main variables of interest in medicine are binary. For instance, died, yes or no. Do you have asthma, yes or no? We often want to estimate the proportion in the population with a particular characteristic. The standard error for a proportion is different from the standard error for the mean. So when you calculate the standard error for the proportion, you calculate using the formula given in this slide. Standard error for a proportion is equals to the square root of p times 1 minus p divided by the sample size n. For example, if p is equals to 0.2 and n is equals to 240, standard error for a proportion is equals to the square root of 0.2 times 0.8 divided by 240, and that gives us 0.026. We can now calculate 1.96 times the standard error of p, which is equals to 0.051. The 95% confidence interval for a proportion, if your sample size is large, let's say 100 or more, is given by the formula P plus or minus 1.96 times standard error of P. If P is equals to 0.2, N is equals to 240, the 95% confidence interval for the proportion is 0.2 minus 0.051 to 0.2 plus 0.051. Remember, 0.051 is the 1.96 times standard error of proportion that has been calculated in the previous slide. If you calculate that, you will get 0.049 to 0.251. And we can interpret it to say we are 95% sure that the population proportion lies between 0.049 to 0.251. Here is an example for calculating the 95% confidence interval for a proportion. In this example, we are looking at the proportion of smoking among Chinese physicians. There were N is equals to 358 Chinese physicians enrolled in the study, and among them there were 38 smokers. If we calculate the proportion, we say 38 divided by 358 and we get 0.106. The example is continued in this slide. Remember the number in the sample N is equals to 358. The proportion of smokers where we divided 38 by 358, we got 0.106. The standard error of proportion, which is calculated by square root of P times 1 minus P over N, is 0.016. And if we multiply 1.96 times the standard error of P, we are multiplying 1.96 times 0.016 and we get an answer of 0.03. Therefore, the 95% confidence interval is given by 0.106 minus 0.03 to 0.106 plus 0.03, and the answer that we get is 0.076 to 0.136. We can interpret the result by saying we are 95% confident that the proportion of smokers among Chinese physicians lies between 0.076 to 0.136. To make it easily understandable, we can convert to percent and say that we are 95% confident that the percentage of smokers among Chinese physicians lies between 7.6% and 13.6%. We have come to the end of this session, and in this session we looked at how to calculate the 95% confidence interval for the mean and the 95% confidence interval for a proportion. In general, the general formula for calculating 95% confidence interval is the sample estimate plus or minus 1.96 times standard error. Confidence intervals is one way of generalizing results from the sample to the population. A 95% confidence interval for the population mean is the interval in which we are 95% confident that the population mean lies in. We can also use theta to calculate 95% confidence intervals. For any questions, you can email me using this email address given in this slide. Thank you.